Okay, tuloy natin. So, next is we're going to apply seismic loading dun sa ating structure. So, yun yung pinaka-last dun sa list natin. Yan. So, we have 1 to 4 already. So, dead load, live load na LR, reducible. And then, yung dalawang wind directions natin. Now, ang susunod dito is mag-create na tayo ng seismic loading. So, ang seismic loading katulad ng wind na kailangan natin i-define yung kanyang parameters. So, unang-una, establish muna natin yung mga details galing sa code. So, it's under 204. Ay, 208 pala, earthquake. So, remember na ang basis ng seismic loading or earthquake loading is UBC 1997 for 2015 NSCP. So, lahat ng information na kailangan natin, dito natin kukunin. No? So, let me start by clicking on seismic definition and i-click natin yung add. And here, we're given options to add information. So, ang unang lalagyan natin is yung seismic parameter. So, first is provide tayo ng type or yung code base natin. So, that would be UBC 1997, like I said. Now, you have the option to include accidental loading or hindi. So, unlike sa wind, mas konti yung ating nilalagay sa seismic. So, una is yung zone. Importance factor. Yung R values, kung ano man yung gagamitin nating type. And then yung nearness factor. And then yung CT value natin. So, isa-isayin natin. No? So, zoning is can be found under figure 208-1. So, since ang assumption natin nasa Baguio, nandito, so nasa zone 4 siya. So, ano yung magiging Z value natin for zone 4? Okay, so hanapin lang natin yung mga parameters natin. Ayan, so zone factors, ito. So, Z value natin is 0.4. Ayan. Nasa zone 4 tayo, so 0.4 yan. Importance factor, since ang category ng structure natin is category number 1, ay number 4 pala, no? Or category number 4, so standard occupancy tayo. Ngayon, ang magiging I value natin dito will be number 1. So, 1 yung value. R value is yung makukuha yan sa may saan ba yung mga R factors natin dito? Malapit na. Ayan. So, eto siya. Now, we have here, para sa concrete, yung susunod dito is steel. Ito yung kailangan natin. Commonly, kapag zone 4 kasi, mas maganda na gamitin natin yung load resisting, moment resisting frames as much as possible under zone 4. Pero yung sa configuration kasi ng structure natin, meron tayong bracing. So, we have a bracing. So, tingnan natin kung meron tayong brace dito na category. Building frames, buckling restrained. Yan. However, composite, eccentrically braced. More on dual kasi itong letter D. Cantilever. This one, masonry na. No? So, either gagamit tayo ng letter B or letter C. But since, like I said, mas maganda na gamitan natin ng letter C. So, since still yung pinag-usapan natin, let's just say na ang magiging primary na source natin is either special or intermediate or ordinary. Now, it depends upon yung configuration ng structure natin. Ano ba yung mga assumptions na gagamitin natin. Later on, dapat consider din sa connection design yung option natin. Kung either ordinary, intermediate, o kaya special moment resisting frame. Now remember, it's all about ductility. The more na pataas yung options natin dito, the more na mas nagiging ductile yung structure. Best is we choose yung special moment resisting frame. Sa actual design, dapat kino-consider natin yan soon, but as of now, yun, dapat ito yung ginagamit natin as much as possible. Pero ang mahirap kasi dito is that due to some of yung complexity ng calculation, medyo mas mahaba yung required na calculation dito. Sometimes medyo mas mahal because of yung specialized na design natin sa connection. Mas magiging detailed yung design natin ng connection as well as yung mga member. That's why may trade-off din. So for yung example natin, let us assume na ang gagamitin natin is IMF or intermediate. So tandaan natin yan, pagdating sa design yan yung magiging factor natin. So IMF tayo. Ang R value natin dito will be number ayan. So 4.5 dito. So gamitin natin yung 4.5. So going back dun sa discussion natin ng seismic loading, yung base shear is inversely proportional dun sa value ng R. So the more na tumataas yung value ng R, mas nagiging maliit yung ating base shear. So kumbaga somehow possible na mas mababa yung magiging value natin ng base shear the more na gagamit tayo ng special moment resisting frame. Yan. So of course, kapag ordinary, mas malaki yung magiging base shear natin. Anyway, dito, for both directions, 4.5 yung ating gagamitin. Since, although, along the direction of dito, magkaiba yung framing system natin. Yan, magkaiba sila kung tutusin. Yan. They're different. Dito, parang naka-brace tayo. And then dito sa direction na to, wala tayong bracing. Rather, yung framing lang natin yung magiging primary na factor. So maybe, mas maganda nang gawin natin, yung may bracing, gawin nating IMF, and then ito, gawin nating SMF. Right? So, anong direction ba yung SMF natin? That is along the X. So, ang SMF, ang factor niyan is 8. SMF, yan, itong dalawa. Just for the sake of yung example, no? But, actually, pwede mong, depende sa discretion mo, which cascades to your design later on, yung design inputs mo. Pwede mong piliin kung ano yung gusto mo dito. Like I said, discretion mo. Basta susundan mo yan, you will be consistent until dun sa connection design. So, soil parameter, soil type, wala tayong information regarding yung sa site. Wala tayong walang data regarding that. So, never mind. Let's just assume some values, but the information can be found under seismic soil type, no? So, ito yung pwede natin gamitin. You can use them as your basis para ma-identify mo from A until F. Hard rock hanggang lalambot ng lalambot. F, kailangang may special tayo na consideration. So, let's just assume a relatively stiff soil parameter. So, D. Let's use number 4. Or maybe number 4 ba? Yeah, number 4. Pansin natin na hanggang 5 lang, wala tayong 6. Kasi yung 6 is special case. Okay, so letter SD tayo, no? SD. Ngayon, ano yung magiging nearness factor natin? That would be NA and then NV. So, kailangan muna natin kunin yung seismic source type. So, ito yung mga parameters na kailangan natin tignan. Una is, ano ba yung may mga fault line ba? Ano ba yung magnitude na pwedeng i-produce or na-produce or possible na i-produce yung activity ng fault line na yun. Yan, let's say, yung fault line na malapit dun sa area is nag-produce ng magnitude 8, then it will fall under this one. So, pansin natin yung maximum, no, 8.5, 8.4. Okay, so assuming na since Baguio, it's falling under source type A. Okay, so source type A siya. Ngayon, gagamitin natin yan to solve for NA and then NV. Nearness factor, dito na lang ako. Alright, here. So, nearness factor, so letter A yung source type natin. Assuming na yung site natin is nasa less than 4 kilometers, you can actually use yung available na yung website ng pwede natin gamitin yung fault finder ng Phobox. Yan, fault finder ng Phobox. I-identify natin yung site. So, saan ba yun? Where's that? Fault finder. Ayan. So, ito yung fault finder ng Phobox. So, gamit tayo ng default, valley. And then, pwede mong i-identify lang yung location. So, saan ba yung Baguio dito? Yan, dito. Baguio. So, you can just click on yung location and then i-identify na niya yung pinakamalapit na valley. Yan. Andyan yung information ng distance. So, 100 plus kilometers. And then, ito yung nearest na fault system. West Valley Fault. I believe hindi West Valley Fault yung malapit dito eh. Meron pang mas malapit along here. So, gamitin natin yung isa pa. Gamitin natin yung other fault. Yan. So, mas marami siya. Mas maliliit. And then, saan ba yung Baguio? Here? Anywhere? O yun. So, may mas malapit. Tubao fault line. Ayan. Map 2012. So, most likely, you try to research kung ano yung information regarding yung fault line na to para ma-identify natin kung source type A or what. Well, anyway, assumption is source type A. Tapos, anong distance niya? 6.4. So, nasa in between dito. So, pwede tayong mag-interpolation, 1.2 and then 1.6. So, if you want to make it, do it completely, like 1.2 minus 1 all over, mag-interpolation lang tayo. So, 5 minus 10 is equal to, ano ba yung distance dito, sabi niya? Nawala na. 6.3. So, ulitin natin. 1.2 minus 1 all over 5 minus 10 is equivalent to yung desired na nearness factor natin, NA, minus 1 all over you can use yung lower boundary or upper boundary. Linear interpolation lang yung gagamitin natin. So, walang kaso yun. So, saan ako? Yun. Yung value ng distance natin na 6.3 minus 10. Yan. Use your calculator to solve for n, but I don't want to do that anymore. So, I'll just assume na 1.2 na lang. So, assume ko na 1.2, the more na mas malapit yung fault line, the more na mas magiging critical. So, why not just use yung mas malaki? 1.2. That would be my NA. Right, so NA. Balik ako dun sa software, NA ko is 1.2, followed by NV is, sabi niya dito. Yan. So, NV, category number A, I'll just use 1.6. So again, pwedeng interpolation kung gusto nyo mas detail yung result. CT value, yung makikita natin dito na naka-asterisk, it means that optional. You can let the software solve for you, pero merong provided ng NSCP. So, hanapin natin yung CT value. CT value is under dito. Yes, CT value. So, pag still frame, 0.0853. 0.0853. 0.0853. Period value is, eto na mismo yun actually. Ito yung method A, meron tayong method B, pwede tayong gumamit ng dynamic methodology. So, since may provided na CT na tayo, I think we can just skip yung part na to. Let's ignore this one. Let the software calculate for us. And we add. Yan. We add. And then after nyan, i-click ulit natin dito. And then add ulit. This time is pupunta tayo dun sa reference. Ito yung sinasabi ko kanina na since meron na tayong reference load, hindi na natin kailangang ulitin yung weight. Yan. Andito siya. So, i-add natin. Again, naka-positive yan because doon sa calculation ng weight, doon sa Bayesian calculation, positive yan kasi weight ang pinag-uusapan. It's not vector quantity na kailangan. Technically, vector pa rin kasi it follows yung gravitational acceleration direction. But anyway, we're talking about yung calculation ng Bayesian, so kailangan positive yung W. That's why positive din tayo dito. Unlike dun sa may dead load, di ba? Ginawa nating negative. So positive yan, you can add, you can multiply 1.2, depende sa provision ng code. So far, it fits na kahit 1 lang yung gamitin natin dito. Direction natin dito is of course Y. Yun yung direction niya. So add. And we're not yet done. There's something wrong with yung load case natin. Kasi according to yung provision ng NSCP kasi, kailangan na mauuna yung seismic. Kapag meron tayong mga definitions na to, for seismic, it must be placed before any of yung mga other primary load cases natin. Dapat siya yung mauuna. So anyway, let me just show you kung ano yung sinasabi ko. Mag-error kasi to. So magpa-primary tayo and then seismic muna lang tayo ng isa. We have here horizontal and vertical. Let's use horizontal. Yun yung nasa code natin. Let me call this one as SL. Don't worry, babaguhin din natin to. So add tayo ng isa. And then mag-add tayo dun sa seismic under seismic loading. Okay? So, no need to worry about yung definition kasi automatic na yan. Isa-select, isa lang kasi yung definition natin dito. Unlike sa width na pwedeng multiple. Okay, direction X ko muna. Factor ko is 1. I can include yung accidental eccentricity, torsion, and then natural torsion. May mga factors tayo dito. Now, you can look at yung code kung ano ba yung mga parameters na or yung checks na kailangan natin gawin to include torsion or hindi. So far, yung aking structure is relatively symmetrical. So I might as well ignore this portion here. So, i-add ko lang yan. Okay? Now, if assuming na tama yung ginawa natin, ang susunod dapat dito is, so, again, disclaimer ulit. Yung part na to, mali yung arrangement natin. This is wrong. Yan. Disclaimer lang, no? Mali yung ating illustration. I-demonstrate ko lang. So, after nito sana, kung tama nga yung ating load cases, pwede na tayo mag-proceed dun sa analysis part. So, i-click lang natin dito sa analysis and design. And then, under dito sa command na to, button na to, i-click natin yan. We can now proceed and ask our software to perform the basic analysis na walang print. Just for the sake of yung illustration ng error na sinasabi ko. So, as you can see dito sa command natin dito, may nalagdag na perform analysis. And to check if we have errors, all you need to do is run the analysis right here. I-click lang natin yan or Control F5. Save. And as mentioned kanina, may error. So the error says here that load cases must be defined before any other load cases. UBC load cases must be defined before any other load cases. So mauuna dapat yung Seismic. Now to fix yung problem, pupunta lang tayo dun sa Utilities, Command File, and then dun tayo sa pinakababa. Kasi number 5 siya, di ba? Number 5. Eto yun. So dapat daw is mauuna dapat to. So I'll cut that loading. Pupunta ako dun sa load case number 1. Which is nandito. Yung kinat ko, ilalagay, ipipaste ko na lang siya. Like so. And then, aayusin ko yung order ng loading ko. Load case number 1, 2, 3, 4, 5. Pero actually, dapat hindi ko muna ginawa yun. Kasi, yung load case number 1 ko, isang load case lang ng Seismic yan. In the direction of X. Meron din tayo dapat Z. Kung tutusin, dapat kino-consider din natin yung reversal, yung dapat may negative pa yan. Pero for yung example natin, never mind, let's just use SX and then SZ, this one is Z. Fix natin yung load number natin, load case number 3, 4, 5, 6. Okay? Perform analysis will retain. Tingnan natin yung result and then may mga modification pa tayo dito. So far, walang error. We can run the analysis ulit. Again. And then as you can see, meron tayong tatlong warnings. So I'm teaching you right now recall kung tutusin. Yung different reports. We have notes, warnings, and errors. Pag notes kasi okay lang. You're just being informed. Yung warning is a little bit higher. Kumbaga, information din siya pero possible na mali yung modeling natin. So in this case, most likely may mali dun sa ating model. So tingnan natin yung warning. Warning. So pwede nating ayusin yan. So soft material, eto, never mind. Because this is due to what? Yung dummy. Tanggalin natin yung mga messages. So etong number 1 na to, soft material. Soft material daw because ito yung mga dummy members natin. Yan, soft material. Maliit yung kanyang stiffness. So warning lang siya kasi possible na nagkamali ka ng input. Pero hindi tayo nagkamali. Tama lang. Warning, self-weight is less than total weight. This is according to yung Seismic. Yun. Ito rin is due to yung dummy loading natin. So, okay lang to. And then, this load case has tension and compression. Basahin natin yung maigi. If this UBC analysis has tension, compression, or repeat load, or reanalyze or select optimize, then each UBC case shall be performed followed by perform analysis and change. Now, in our case, actually, pwede nating ignore to, but for the sake of removing that warning, it will not change yung result, but kasi pag pupunta tayo sa loading, yan. Seismic, ito yung loading natin. I-generate niya automatic. Kanina wala yan. Yan. Kapag nag-run tayo ng analysis, saka lang lalabas yung value. Okay? So anyway, to remove yung warning, I can go under command. And then, dun sa load case number 1, ito yung Seismic ko. After nito, I'll just place perform, analysis, and then change. According to yung instruction ng warning. Same is true for load case number 2. I'll save that, close, and then rerun my analysis by pressing Ctrl F5. Now, ngayon, nabawasan na yung warning natin. From 3 naging 2. Let's look at the output. And wala na yung UBC warning. Yan. So, I guess we're done with yung ating input for yung ating seismic loading. Okay, so next natin will be yung sa actual na analysis na. Okay?